This podcast is presented by NXAI, your partner for time series foundation models and physical AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seeberg. The final time that you and I talk, there is one more podcast after this one.
Before the summer break.
Before the summer break, exactly.
Yeah, exactly.
I was going to say that.
No, not the last time we record this episode.
No.
Podcast. No.
We are only at, what is the number we're recording here today?
350.
350, okay.
Yeah, 350.
We can easily do another 350.
Exactly. There are a lot of topics. Let's start with the news part.
Yeah, you do.
Do you have something hot?
No, I do not. And I think you have, so you start. Yeah, please.
Okay. There's a interesting news today because our friend Max Welling, he was our guest, I think 3-4 months ago, raised $450 million. And yeah, he raised a lot of money for a European startup. So congratulations to Max and the whole team. Greetings to Amsterdam. But what I found very interesting is that they are now building an AI materials foundry, and that's now a quote, with more than 45 global partners coming together to achieve breakthroughs in semiconductors, clean energy, and advanced manufacturing. Leading companies including Meta, Nvidia, Hyundai, Henkel, Samsung, Applied Materials, and AMD, and a lot more companies. A very interesting approach to also establish now a foundry there.
Yeah, that's a relatively new thing for me as well. I mean, the word foundry for me is from the chip manufacturing, where in the past, when I was part of this company, Intel, and they would always produce exclusively for themselves. And in the meantime, and I think that was one of the big top-level decisions where some people would support, others would not. But in the meantime, they have become a foundry, meaning producing for others. And I guess the number one name most all of us know there is TSMC. I was just looking because I wasn't sure I could use the word Taiwan, but I guess I can. It stands for Taiwan Semiconductor Manufacturing Company. I guess they're the number one, the biggest, and we don't want to go into the politics of what that means, but for that very reason, for example, the United States, but also Europe, Dresden area, everybody have more production capabilities themselves. Yeah. So there you go. Very interesting. What does that mean? It means that if Casp AI is going to be themselves or other one using their technology to come up with new materials, then each of these foundries, they maybe are going to use their approach and going to be producing those new materials for even others, I guess. I don't know.
Yeah, I think so. Yeah, that's, I think, the idea. Yeah. Interesting. And what I found interesting, because I had a recording with Dunya last week. We will send this episode, I think, in a few weeks. And Dunya is a German startup in the same field. And they have a totally different approach than Max approach. So be curious about the episode with Dunya coming in the next weeks. Very interesting. Yeah.
Looking forward to. As far as I recall, I'm not sure if that's the Casp AI approach, but it's very similar to, maybe it's kind of reinforcement learning, kind of telling the algorithm what it is that you want. And was that not the case also with, what is that? Is that the Google daughter from London?
DeepMind, AlphaFold.
Yeah, there you go. Now, and isn't the idea, developing the new drug, and you take 100 scientists and you take 10 years and you need $1 billion, and then after 10 years you find out it was the wrong approach, right? And that's why you start again, kind of thing. And instead of that, you tell the algorithm what it is exactly that you need the outcome to be. So, and I believe there was maybe one of those two. So I'm very much looking forward to Dunya as well, of what their approach is, to tell the algorithm that's the outcome, and you find me, how I get to the material, maybe chemistry, I don't know.
That's interesting. A small spoiler because you went into details, right? So the Dunya approach is like a little bit the neuro-robotics approach, building gyms for new materials and not robotics gyms. So building labs to generate data, because the missing thing in this whole topic when to find new materials is to produce data at the end.
Oh, amazing.
That's very interesting. And the whole conversation was very, very inspiring. So I think it's the first episode we share after the summer break. Yeah.
Okay. Looking forward to it.
What else do you have, or should I go on?
You can go on. I have two like finishing background pieces.
Yeah, exactly. And then there's a issue with Sophie. And Sophie is a German 30 billion large language model. And the whole community was impressed at the beginning, but then some people looked a little bit closer into the whole thing. And it's a copy of Nemotron from NVIDIA, nearly a copy of Nemotron. There have some test leakage, data leakage topics there. And this was really, at the end, from my point of view, it's an embracing fiasco. So they announced something very big, very big. We have a very big model. It's not instruction tuned, so it's more architecture. It's not instruction tuned yet. But then if you follow a little bit the discussion on X, because on X there's a huge machine learning community discussing the whole topic. I will share the link there. I don't know why they did that, and why they had this data leakage in, and why they only use a Nemotron copy. I don't get it. So it was trained in Munich.
Who is Sophie then? Is it an organization or a company? Or
it's an organization by Fraunhofer and Technical University of Darmstadt, a lot of German universities and stuff like that. And yeah, let's see what's the outcome there. Let's see how it will be used in the industry. So the focus is industrial applications. Let's see what you can solve with this. I think, yeah, it's not instruction tuned yet. It's the next step, the guys told the community. But at the beginning I was, 30 billion large language model. That sounds interesting. And now I'm a little bit disappointed.
Is that the one that was based on several or all of the European languages? Or has that nothing to do with each other?
It's not the Euro LLM. It's German and English, yeah.
Okay. And Sophie, you spell like S-O-F-I or?
S-O-O-F-I, yeah.
S-O-O-F-I. Oh, I hadn't heard of it.
Yeah.
Maybe there is still this thing where specific pieces first get discussed on X, and then they come to LinkedIn, where I typically concentrate on, and maybe some of them don't move there at all.
Yeah, exactly. What else do you have, Peter?
Okay, yeah. So as I say, I have two pieces of background reading, more letting you, dear listeners, go into your well-deserved holidays, if not yet already. You have the first I'm going to share, and I have had them with me for many, many, many months. I could have shared at any time, is a couple of quotes from the play RUR, Rossum's Universal Robots. Oh, interesting, that word, right? Now, which I strongly suggest each of you reading over the holidays if you haven't yet. So RUR, R-U-R, has been written by Czech, Karel Čapek. And the Czech word is Rosumovi Univerzální roboti. It's a science fiction play, 1921. Did you hear that? 1921. That's 105 years old. And in that play, the term robot was first introduced, as far as we know, in Czech language. And that is similar to the word robota. And that seems to be the word for forced labor or hard work. That's, of course, already important to realize. Now, the play takes place in a factory that makes artificial people called robots. By robots, by the way. That's also in itself very interesting. Now, they're actually less what we've been used to today and what we call industrial, mechanical. They are more biological. And still, I guess today we would rather call them humanoids. Now, there you go. I'm not going to spoil the story, but maybe I'm going to share 3 quotes that just come out of somewhere out of the book. And maybe you get a feeling for what this is all going to be about. In the beginning, it says, man is too complicated. A good engineer could make him more simply. I forgot who said that, if it was the writer or one of the characters. It's not important. I guess, though, very interestingly, when I was looking at that again this morning, this could be said, as a reason against humanoids in factories, right? It's what I've always been saying. And these days you see hours and hours of discussions about humanoids, number one, and about humanoids in factories. Now, there you go. Number two, I'm going to share. So many robots are being manufactured that people are becoming superfluous. It's like, what do we need humans for? So that's where it's getting dangerous, I guess, for humans. And the final one I'm sharing is even more so in the final quote. We, the first international organization of robots, proclaim man as our enemy and an outlaw in the universe. So I'm going to stop here. If that caught your attention, as I suggest, it's a rather nice story. I think it's a play. It's a play. There's a wonderful picture there. If you look on Wikipedia or elsewhere, maybe, which is a play out of the character. You can see how the robots at that time looked like when they were playing the robots.
Perfect. So it's a summary on the beach.
Yeah, you can. Sure, you can. I guess it's going to take a couple of hours, maybe 2 hours, kind of reading through it. So, yeah, it's not as big as what I just finished this morning, which is a crime. What is it in English? Tolstoy, Peace and War and Peace. Right?
Krieg und Frieden.
That was 60 hours of listening.
War and Peace or Peace and War?
Peace. It's a Peace and War and Peace, I think.
But it's not AI related content here, Peter. Please go on with your AI related content.
I'm only saying 60 hours. And then number two, I'm going to share very strongly related, I guess, to robots and how we humans can make sure that they will not rule against us, which is the 3 laws of robotics, right? I think most of you have heard of them. I'm just going to share them one more time with you. There was a reason just a couple of days ago. So it started, and that's from 1942, from Isaac Asimov, right? He says, number 1, a robot may not injure a human being or, through inaction, allow a human being to come to harm. So you can very nicely relate this already to the book about, or the play about robots.
Interesting. I will record an episode today with the NVIDIA guys with their new HALOS safety approach when it comes to humanoid robotics.
Okay. Ask him if they are aware of the 3 robot orders.
Yes.
Number 2, then, is a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. That's what he always does. He always goes back to the first one. And number 3 is then a robot must protect its own existence as long as such protection does not conflict with the first or the second law. And then a couple of years later, and he's been writing in his time, this is 1942. So again, this is what, 80 years old, right? He then realized that he should have put a law before, which he then called the Zeros law. And it is a robot may not harm humanity or by inaction allow humanity to come to harm. And that's, again, very interesting. That applies perfectly to the first piece I just talked about. So again, if that's of your interest, those of you that have not yet been reading or looking at, iRobot, for example, great movie, is based on his story. So he's been writing a lot of what at that time was science fiction. And just to share, my company called Asimovero, it's a play on words, some Asimov and Vero, more like the Italian, Latin, true, which I chose at that time, as we are living in times of Asimov's ideas coming true, right? Autonomous driving. And I think we're going to hear a lot about these laws again, as, we, not that strongly,
as I record the episode.
As you do, yeah, most likely. Yeah, not only that. I think in the industry, we haven't necessarily with industrial, but again, if we're going to continue with the humanoids, which again, I question at least if we're going to be having them in an industrial environment. But if they go outside, I think we're going to be hearing and seeing a lot of these laws. There you go.
Perfect. So let's switch to the main part. I did an interview with Doudou BA from Sweden. He's a data scientist at Maersk. Maersk is a big logistics company. I think everybody knows the containers Maersk, but he's also an entrepreneur and he's building his own startup and his own ideas. And we talked about his new, let's say, AutoML time series foundation model approach. Very interesting for data scientists. Let's hear what Doudou will tell us. Yeah.
Very much looking forward to. And then we're going to have at least the second one. I think that's Jakub that we're planning, right? A week later.
Exactly. Last episode of before the summer break is Jakub Tomczak with some information, with some topics from the US.
And then you and I are going to be back in about 4 weeks, I guess?
Beginning of September. So first
roughly, yeah.
Thursday in September, we are back.
Very good. Robert, thank you very much. Have a great time. Same for you, dear listeners. Have a wonderful holiday and hope to have you with us again in latest in 4 weeks.
Bye-bye.
Thanks. Bye-bye, Robert.
My name is Robert Weber, and it's a pleasure to welcome Doudou BA. Doudou, welcome to the podcast.
Thank you, Robert. Welcome. I'm very happy to be here, to be joining a AI Industrial podcast.
Live from VivaTech in Paris. Before we start talking about OctOpus and your topics, please share some impressions from VivaTech. What impressed you most?
I mean, Robert, VivaTech is one of the greatest Europe's tech event. It's huge. Like, I mean, you have a lot of people, big people. Yesterday, we got Jeff Bezos here. We have Yann, LeCun. We have really big startups all around the world, from Europe, from the America, from Africa. Like a lot of tech and startups, exhibitors. It's just amazing. Like, I do love the ambience here at VivaTech.
Okay, so you mentioned Jeff Bezos. Did he talk about Prometheus, or what was the topic?
Yeah, I mean, it was a lot from people from Blue Origin. It's also a lot of topic around the AI and the discussion and everything. It was pretty fine discussion that we had there from Jeff Bezos.
So, from a technical perspective, what was impressive to see? Some new stuff, or is it more, let's say, a meet and greet event?
Actually, I mean, it's a great opportunity for a founder like me, to meet with potential clients, make your product known, be in the Hall of Fame and talk to investors and a lot of people actually exhibiting. You also discover technology. You also learn, right? Because people doing conferences, you basically get to talk to them and you basically have new techniques, new ways to do it. And you basically, when you're sitting just in your room or your corner and developing some stuff, you might not know what's happening elsewhere. And here is a chance where you see like robots some people doing AI physical, some people building like amazing AI solutions. It's really basically the best way, to network and basically learn and share and get your products known better.
Can you share 2-3 examples? What impressed you most?
Oh, yeah. The Yann level talk yesterday was pretty impressive, right? I mean, Yann is someone that we follow. It's one of the pioneers in the AI that we know today, right? So, yeah, listening to him and being in front of him was a great opportunity, of course.
What was his main message?
I mean, yeah, I know what he's developing right now. But maybe he might be like, it might be a little, in conflicts or contradiction with the current AI solutions that we have, the LLMs and the philosophy behind it, because Yann's position has been clear, right? Over the past years, he's been talking about it. He doesn't believe that the AI solutions that we have today are that intelligent. So that's why he's proposing his new methods and methodology with his team. And I pretty much, I think, we are getting there, right? Intelligent or super intelligence has different way of perceptions, right? Some people might think, AGI could be something that does prediction, and some people that might think that, just a system that predicts the next word is not so intelligent, right? Probably we need some other system that really understand human and that are human-centric and that really answer from the human perspective, that have the point of view.
Did he tell something about Jepper, about his new achievements or some technical insights, or was it more bashing LLMs?
Yeah, the discussion was large, right? But he talked about it very, very quickly, right? We had an opportunity to see, he demonstrated what he has like with their own technology and what they have been developing even like in the past with Meta, and today, his project that he's running, with mostly in the computer vision side, right? But probably I didn't attend the full Yann LeCun's pitch. So there was a lot of people and it was crowded. You you barely get chance to get in. So, but when I got in, yeah, absolutely, it was amazing to see him talk, and yeah, a lot of topics that he brought. And when it comes to the question about his technology, they are moving fast. I think they are developing great stuff, and we are yet to see them. Right, we don't have like clear deadline on when they are releasing their solutions. But also one of the solutions that he mentioned, right, is that AI for contribution, right? So there is there are some repositories for people like you and me or anyone that would like to contribute in building AI that is safe and for humanity, that will be human-centric. So those people can just come up with their own data and use some GPUs and some tech stack and contribute. But basically, it's just like GitHub contribution, but for AI. So this is some of the solution that he's proposing for now. So let's see how it goes.
Mm-hmm. Okay, perfect. So let's come back to your mission at VivaTech. Before we start talking about your solution, please introduce yourself briefly to the listener. Who are you? What do you do? Why do we do a podcast interview with you?
All right. Thanks, Robert, just for the opportunity. So my name is Doudou. I'm the CEO and founder of OctOpus. OctOpus, which is an autonomous AI data scientist, which transforms raw data to business decision and machine learning models. All right. Why am I at VivaTech? VivaTech is one of the greatest events here in Europe. So it's a great opportunity for me to exhibit my startup, to showcase, to do some demos, to show to a lot of people, right, how and what we are building and how OctOpus can take the AI revolution and the decision into a next level. Yes, so it's a great opportunity, of course, to meet clients and investors and make your product known by millions of people.
Okay, so let's talk about OctOpus. What is it and how does it work? What can it do, your approach?
All right, sure. OctOpus is an autonomous AI data scientist. It basically does the full-time job of...
So it's a Claude for a data scientist.
Yeah, it's more like Claude, but that is very much specialized in data science. It knows data science, the entire data science loop, and it only does data science. It doesn't do anything else than data science. It's basically your data science teammate or your data science employee. Imagine like an AI that you say, hey, OctOpus, can you connect to my database? And it just connects to your Databricks, right? You tell, hey, OctOpus, can you connect to my sales data? Can you import it? Can you clean my data, transform it, remove some columns, remove some rows, combine or merge my data, just as you would be doing like in the data, a data engineer would be doing or processing the data or transforming it. Or you say, okay, I want to analyze, I want to know about my sales last month or last week, or what about OctOpus? You build a dashboard for me and it does it, right? But what's more impressive in OctOpus is it can build and train models live for you just by knowing your business question. Let's say if you would like to forecast revenue, you just say, OctOpus, this is my data set. I would like to forecast revenue. And autonomously, OctOpus will write a plan, hypothesize, as a data scientist will do, write a code, build and deploy machine learning models. And it provides very, very accurate and reliable results in a very short time.
So what is the difference to a Claude agent or a Claude application? Is it an AutoML approach? Can you evaluate a little bit more?
Yeah, absolutely. So you see, AutoML tools in general, right? They are living in the past, right? It's before the AI era, right? You have a lot of them, but it's just a bunch of models. They run in parallel and tell you, oh, okay, this is the best model because it had the best metric, you know? It doesn't tell you about what's overfitting or underfitting. It doesn't really, truly understand the job of a data scientist and doesn't reason at all. So if you take tools like Claude Code or Codex, they are really good for coding, right? They still need, an expert to sit and give them instructions. So if me as a data scientist, right, if I would use Claude Code, I would go to Claude Code and say, hey, this is my data. I would like a model. I have to give precise instructions so it can write a code for me. But since Claude Code is not designed to do data science or machine learning, it would not be efficient, right? It can just write a code for you, and maybe you take your code, bring it in a notebook, try to train a model. If it doesn't work, you get back to Claude Code and you iterate until you get some reliable models probably and deploy it. But OctOpus, before you even know what you want to do, OctOpus can guess, understand, oh, you want to predict this column and let's do it, right? And it does it very reliably. What's impressive in OctOpus is a non-technical person, let's say a salesperson, a managing director, I don't know, a marketing specialist, they can just be data scientists without having like an expertise in data science or a background in traditional data engineering.
It's a web application, right? And so what is in the back? It's a combination of LLMs and time series forecasting, tabular data stuff. Can you share a little bit the structure of the solution?
Sure. OctOpus, you can access it to in live version, right? OctoOpus.dev, right? It's the server in the cloud. But also you have the option to download it and use it directly in your Mac, right, in the desktop, and basically it can read the data from your laptop, and it can use your CPU, your GPU, and your own memory, right, and build and train models in your own laptop. But if you talk about the cloud version, you basically can ask OctOpus to connect to any of your data providers or your data warehouse. Let's say you have Databricks or whatever, Snowflakes, Microsoft Fabric. It can just connect to any of your data flows and basically build and transform your data and analyze it and build models and deploy it. Now, when we talk about the stack, OctOpus is an agent. OctOpus is not an LLM. It uses LLMs. It uses the intelligence of LLMs it uses the knowledge of LLMs like OpenAI's ChatGPT or GPT-5 or Claude's Opus, right? To reason, to write the code. But what's more important in OctOpus is it knows what model to use that fits with your data set and builds and trains the models on top of that. So it's already embedded. It has knowledge and awareness of a lot of models, like one of the most powerful models today that we have for time series, like T-Rex, XLSTM, and so on. So it all is already aware of the data set that would the model that would work on that data set. It directly picks those models and tests them on your data and iterate until it reaches the best model. So right now, you could say from a machine learning perspective, you can have from linear regression to more powerful models like T-Rex or T-Rex or maybe XLSTM, and basically it just picks those models and try them and test them and tell you, okay, this is the best model and why it is the best model, and answers your business question, right? You started with a business question and it ends with a decision at the end, not just a score. Mm-hmm.
But the magic is then the MPC connection to the Chronos, to the Times FM, to T-Rex or whatever.
Absolutely, to all these model families. So there is an MCP server connection. So it's able to actually redirect to the model that it should be choosing, right? And wire the technology that is there in the back, and just train those models directly from the package it already installs in the service.
So let's assume I share my data and then I get a prediction. Does the model also gives the user an interpretation? What does it mean at the end?
Absolutely. Imagine like if you just train a model, but it just gives you an accuracy or a result, and you don't even know what's the metric. What does it mean? What is AUC, right? You can ask to OctOpus, but why? Right? It just doesn't give you a result, right? But it gives you the entire narrative and answers why what it just did, right? Why it did it, what are the hypotheses, and the result that it got, right? It can explain you, okay, the metric, what it means technically or in your business use case, like what does an AUC score mean? What does an MAPE mean? What is RMSE? What does it mean in your business question? So it does the interpretation, and after the training of the models, it can do the interpretation, and you just ask, what did you just do? And why did you do it? And OctOpus can answer all those questions.
You mentioned training, but when you talk about Chronos or Times FM, T-Rex, it's a foundation zero-shot model, so you don't need to have a training, or do you fine-tune the models in the back?
Yeah, basically, it uses those models, and basically, it runs them, right? So when we talk about Chronos, like the foundational model, so basically, it can use them directly and run it, right? But you probably will need some fine-tuning, right, of those models. So this is where OctOpus can actually do iterations on different approaches and try to see what approach works the best, and basically build and deploys the models at the end. So if you see machine learning, right, a lot of data scientists are doing the mistake of thinking that like they should start with the model and not the data. But imagine like if you have a data set with like 100 or 1,000 rows, right, and you need to do prediction on that data, you probably don't want to go for deep learning models, which will only lead to overfitting or the model is just not made for your data set, right? So OctOpus can take the decision on what model to use on that specific case. I believe on model universality, of course, there are models that are very much powerful and that most of the time can work. But I do believe there is only like a model that fits your data and that works really well with your data, even though some of the models, most of the cases, are really good in doing some time of forecasting. Let's say how T-Rex does with time series forecasting.
Okay. So you mentioned data scientists, right? It's also a topic for data science on tabular data. Is it also an option, or is it only time series, or do you have different domains where OctOpus is working on?
So right now, OctOpus is more focused on tabular data. So be it like time series or prediction or classification task or prediction, or any prediction task, right? But that's the data science or machine learning part, I would say. But above that, beyond that, OctOpus does the full data exploration, the data analysis, the causality, the statistics, the studying the data before even choosing the model. And it goes with a full loop of hypotheses. So let's say if it uses the first model family, it goes with a hypothesis. And then after the training, it says, okay, this model gave me this result. So I'm going to optimize it and maybe add some hyperparameter tuning. And if it doesn't work, it just decides to discard it on its own and choose another family of models and decide to fine-tune that model and just take it to the next level. So it does work pretty well for tabular data set, mostly, but also unstructured data, right? We are today more focused on tabular data.
Okay. You're focused on unstructured data or tabular data?
Yes, tabular data, but also it does for unstructured data, right? For instance, if you have PDF files or those documents, it can also process and clean your data before it actually does the training.
Okay, but the main pillar are time series foundation models in the back, or am I wrong?
Yes. I mean, like main pillar, most likely we use a lot of models from NXAI. We do also use, classical machine learning models, from linear regression to boosting and gradient families. Yeah, so it's a stack of models that is behind, so that it decides to choose on its own decision, basically, it's without being instructed. So, but also someone might come and with their own benchmark, right? Let's say someone uses LSTM or XLSTM on their data set, right, on their business data, and they got some score, and they would like to actually improve it. They can just come with their own code and the structure and the business data and just say, okay, this is the result that I've obtained, and I would like to boost it. I would like to improve it. And OctOpus will take it from there, from where you left, from your parameters, and just improve it and give you better and reliable models.
Okay, interesting. So I'm very interested in this reasoning capability after the prediction. How do you do that? How do you interpret? Do you train the LLM, or is that a RAG topic, or is it a knowledge graph approach, or how do you handle this reasoning, this understanding? What is the result?
The power of OctOpus right now is the brain that it has. OctOpus is able to take its own decision and decide it. So basically, it's just like I, as a data scientist, gave my brain to OctOpus, how a data scientist should work, how a data scientist should be thinking, how a senior data scientist would be doing in front of this situation or this case or this situation. Basically, the full data science knowledge, it has access to it and it can decide. That's the whole brain of OctOpus. So, of course, we have knowledge graph. Of course, we have the regular time series or tabular data set, of course. But I think the power is the intelligence, right? And how does it use the intelligence? So today, if you see LLMs, right, they know about the world. They know a lot of information. You can ask them about any topic in the world, about data science. You can ask about healthcare or finance or anything. And they are able to answer. But the particularity is OctOpus is its specialization. It does data science, and it only does data science. It cannot answer your a question that is out of its scope, right, of a data science or the data that you gave to OctOpus. So basically, it remains everything that it does is connected to your own data. So it doesn't pick anything from the internet. For now, we have locked it, right? It doesn't pick anything or doing some RAG. But what it's doing is pure intelligence and the setup and the agentic setup that we gave it that enables it to think before it takes any decision.
Okay. But is it an option when I run it locally in my environment also to implement a RAG approach to my data sets so that my people on the shop floor can understand, and because I have maybe very specific time series topics that I can train the LLM on my approach on my data sets?
Yeah, it does it. Actually, we have a desktop version that people can just download and install in their laptops, and it will use your own CPU and your own GPUs, and basically you give it access to your folders, basically, and rise to install or anything in any package in your laptop. But basically, if you ask it, okay, OctOpus, connect to my folder that is in my, I don't know, local files, right? Basically, it can access it and read that data and basically merge them or transform the data and do anything, any instruction that you would give to OctOpus to analyze it, to give you some insight, or to, if you would like to take a business question, you just come up with a specific business question and it answers it with reliable models and decisions, and can build dashboards and present you basically the whole information. So of course you can be doing that, but OctOpus does natively already the entire RAG that you were talking about. It is already native. It's AI native in OctOpus.
Okay. So what is on your agenda? What is on your technical agenda and from a business side?
So right now we are integrating more and more models, right? We want more powerful models in our stack, right? Because also, I mean, business, what they want is reliable decisions and fast, right? They want powerful models, they want reliable models, and they need to take decisions fast. So OctOpus today can, I wouldn't say replace data scientists, but it can be really, really, really good assistant for the data teams as well as the business teams. Let's say a CEO can just go, or a marketing specialist or sales, just go to their car, while they're driving, they just talk to OctOpus in their phone. Hey, OctOpus, can you tell me how many sales did we do last month or yesterday? Or can you tell me like how many, what will be our revenue next month? And it just writes some machine learning models or train it and deploy it and just gives you the answer, right? It ends with a specific business answer. So I think this is what's the power of OctOpus, and we are improving it, right? So what we are doing is talking to our customers, understanding our customer needs, and keep iterating from there, because this product is built for customers, and it's actually the customers that gives us feedback, and we only tailor it to the customer's needs. So we have a full pipeline. Today we have over 9 enterprise POCs that we are running already in Europe and US, and as well as in Africa. And we are also doing the B2C side. We have over 200 users. And it's pretty much right. It's cool, right? After 3 months of launch, we are gaining attention. We are today here at VivaTech, met a lot of people. People are really interested. You could see like the interest that they had for OctOpus directly live from VivaTech here in our exhibition. So people are trying it. They are impressed, and they are giving their card, and they want more and more network. So we talked over 10 customers here already that are willing to partner with us and have a follow-up. So it's great, and we will keep iterating from there.
So you're going to an early stage VC fund rounding, or what is the idea?
So right now we are very much focused more on the client acquisition and doing the deals, right? Investment, it can be cool, right? But for this type of business, I think, right, we probably don't need VC investment right now, even though it can help, of course, boost like trips like here in VivaTech. Of course, you need something to cover it and cover the trips and paying all the stack behind, right? You have to pay for the cloud and the AI credit users. But I think, right, getting to an accelerator like Y Combinator, that would really help, or any other accelerator that can enable us, getting those cloud, getting this credit, and partnership with other AI providers, especially teams from NXAI team, that would boost and enable us to use your models and actually enable our customers to have reliable models and reliable decisions using OctOpus.
Perfect, Doudou. It was a pleasure. Thank you very much for the insights of your OctOpus platform time series forecasting approach. All the best and greetings to Paris.
Thank you very much, Robert. But now I will finish with this question. What does OctOpus mean? Where does the name come from?
So the octopus has so many arms, and so the octopus can handle so many different models and so many different data sets.
Absolutely. Absolutely.
And this is why it's called OctOpus.
That's a good insight, right? Octopus is agentic. It can do different tasks at the same time. They are related to data science, from data analysis or transforming your data, building models. It's agentic, but also, Octopus is one of the most intelligent animals, and it has brain and it reasons, right? But what makes it also special is in the name, there is octo, like octopus, and then opus is the most powerful model from Anthropic, which is Opus 4.8, and that's why actually what Octopus uses for its reasoning, for its brain, and for how to decide on what model to choose, and etc.
Perfect. Doudou, it was a pleasure. Thanks a lot.
It was a pleasure. Thank you, Robert.